Here we're going to implement a basic switching circuit, switch and drive it using PSIM. So here we have a really basic circuit with a voltage source and a resistor as a load. And we're going to insert a switch here so we can turn the voltage on and off as it connects over the resistor. So what we need to do first is find a switch. So under power switches, there's a bunch of switches here. All of these are very important for power electronics. But first we're just going to do an ideal switch. So we take this bidirectional switch and we just insert it here. It'll just put itself right in there. And we're going to label it S1 and show it. This initial position here is 0 if it's open or 1 if it's closed. So we'll start with open. So here is our switch. And now we're going to drive the switch. So we need a few different blocks. We need to go to, not control, but to other and switch controllers. Here we have an on-off controller. We can add this here. We have a little controller. It just drives the signal. So if we're going to put a voltage signal in here, it's just going to drive this switch in the way that we want it to. So now we can just attach a voltage source here, and we can use a square wave. That's a very common waveform for driving a switch, especially in switch mode power supplies. And we're just going to connect this guy here, and we're going to add this, copy and paste this ground symbol here so that everything is referenced to ground. Now we're going to look in this square wave signal. We're going to name it VD for driving, and our peak value is 1. Our DC offset is 0. This means it's going to go from 0 to 1. We can choose our frequency. Here we're going to do 1,000 hertz, and then our duty cycle we're going to go with 0.5. And we're going to display this value here. And now we'll just show the duty ratio just for clarity. Okay, so here's our basic circuit. Let's check our parameters. We're going to run for 0.01 seconds, and let's see what happens. So we're going to run our simulation, and we get our two signals here, and this time we're going to put them together. So we're going to look at the voltage and the current together on the same graph. Okay, so we see that we are getting some switching occurring here, so our voltage goes up and down. Let's also check the switching signal just to make sure it's working correctly. So we have to go back and we're going to add a new voltage probe. Let's just put it on the input to the switch just to make sure that our switching signal is as we expect. So here we'll go VS for switching, and let's put S1 for the switch signal. Okay, let's run it one more time. We're going to add at the bottom here this switch signal. Okay, great. So we have our switch signal going from 1, 0, and then we have our signal when the switch is on. We have current and voltage are applied across the resistor, and then when it's off, there's no voltage and no current across the resistor, so it goes to 0. Let's say we want to zoom in on just, let's say, 2 periods of this system. So we want to only simulate for 2 milliseconds. What we have to do is go back to this simulation control, and we're going to change this to 0.2 seconds. So now let's run that. Okay, and now we've zoomed in on just that section. If you notice here, some of these lines are they're angled, right? They're not quite completely straight. They should be completely straight based on our idea, right? It's an ideal square wave. Because of the simulation, because there's a certain time step, if that time step is too large, you will get more rough signals, but your simulation time will be faster. We want a nice sharp angle here, so a nice square wave here. So if we want that, we can go back and change our time step and actually make it smaller. So we're going to make it 10 times smaller, 1 to the negative 6, 10 to the negative 6, and then we're going to rerun the simulation. And we see now it's very straight, we have very clean lines, and although it didn't matter much in this simulation, it did take longer to do the simulation. So when you're simulating a switch system, you need to be aware of the simulation control and look at the time period that you expect to be simulating, so pay attention to that, and also pay attention to the time step. It should be small enough to get the accuracy you need, but if it's too small, it can take too long to simulate. So you have to balance between those two things. Another thing to note with the trial version of PSIM is that the number of data sampled is limited to, I believe, 6,000. So you want to divide these numbers correctly so that you don't get your data cut off. Okay, so pay attention to that. One more thing I want to mention is that when we're in the Simview looking at our waveforms, there are these buttons down here that can help us analyze our signals. Specifically, we have this average button. If we click here, it'll show us the average value, this is over the full period, of each of the values that are shown in the graph. So here we can see all the different values here. And we can also look at the, not just the average value, but the RMS value. If we have switching waveforms, we want to look at the RMS value. We can also look at the power factor. And this only applies when you have current and voltage multiplied on the same graph. So this top graph, we have current and voltage. So here we can actually get a power factor here, whereas if it's just one lonely signal, it can't do a power factor. Okay, and so there's other things. We can also look at THD down here, the total harmonic distortion. In this one, we would have to input the fundamental frequency for it to do the calculation. If we do that, we can get the total harmonic distortion out for our different signals. So those are useful tools to use when analyzing your waveforms. Okay, good luck with PSIM.